totally cool if you do it. I'm not telling you not to do it. Just making sure you have more. Alright, let's look at it. So there's 3 ways to do it. We've learned 3 different designs, right? And you could choose any one of these. It didn't tell you, hey, you have to do this using whatever design. So the easiest thing I think would be completely randomized. So I would say put on, and that means we just don't worry about any of the lurking variables. Let's start there. What are some of the lurking variables that will affect the water damage? Right? Activity level. So if I'm someone that goes home and sits on my couch, probably not going to be a lot of water damage. If I'm out there doing stuff and I'm wearing the boots all over the place, it's more likely to be. What else? Yeah. Well, they would get the same amount of rain, though, wouldn't they? If they're wearing, at the same time. What else could affect it, though? So, well, okay, that might. So some people that I've seen do this before say, everyone in the study wears the boots for the first 3 months. And then everyone in the study wears the other boots for the next 3 months. But then, your weather would be a huge lurking variable, right? The first 3 months might be in the middle of summer and it's dry, there's no rain, and then the next 3 months are, it's fall and muddy and winter, so those boots got a lot more water damage. But then would we know if it was because of the boot or because of the weather? We would. So don't split it up by months. But anyway, completely randomized. We're just not going to worry about any lurking variables. It's the simplest thing to do. Put on our names and hat, mix them up. U50 wear the new boots for 6 months, U50 don't. At the end, we'll compare water damage. I might do it completely randomized. I think it's the easiest route. That's what I would do too. Block, if you decided to block, you could block on anything you think is important. Make sure it would matter, though. I'm not going to block on, hair color. I'm I'm not going to block on, I don't know, people that eat cereal for breakfast. So I can block on activity level. I think you could say I'd block based on like job type, maybe. Like if you're an office worker or a non-office worker. I think you could probably say you could block based on gender. I think it's possible that might matter. So whatever you're blocking on, we block based on, you can kind of insert your own thing there. And then I would say put the 50 most active people's names in a hat, mix it up. 25 get the new boots, 25 get the old. Over here, do it again for the less active people. 25 get the new, 25 get the old. After 6 months, we compare water damage. This one I think is really cool. So I was as an AP teacher, you go to these conferences with other AP teachers. And they kind of like, it's actually not that bad. Yeah, but again, I'm like a huge nerd. So. And they'll give you these problems, and they'll kind of throw out challenges to you. So they gave us this problem, and there's 20 teachers in the room or whatever, and almost everyone did the first method, the completely randomized, just like most of you guys did. Some people did block, and then they said, okay, now try to do it with matched pairs. And you don't have to. That's not required for this question. But I want you to try it. I want you to take a minute and think about how you could do this using matched pairs. And you don't have to write it out necessarily, just kind of think through how could you do this using matched pairs. Let me take it a step further because I can already hear people starting. So one thing you can do would be like list people by activity level, right? And then the top 2 most active, what would you do with those 2? One gets the new boot, one gets the old. The next 2, okay. But I want you, let me rephrase. I want you to see if you can figure out a way to do it matched pairs where you are your own control group. So, remember, like, what's the most similar thing to Maya? Maya. See if you can use that and match pairs and test groups. And it's really like nobody in this class, all these teachers, I didn't figure it out, no one really figured it out. But once someone said it, I was like, oh my god, it's so simple. So if you're the control group, I don't want to say, no hints yet. You got it? Those are very good.
Okay, so every
Quiet. Or randomized. So then you go through like that's the that's perfect. Like it's so simple, but it's like really good. And it's hard to think of. Yeah. It's not bad. There's a better way. That's not a criticism. It's just yeah. It's not bad, but that's possible that you'll get like. So some of you are saying like switch every day, or like even you can switch every hour if you want to get crazy with it. But isn't it still possible that like even days have worse weather than odd days? It's possible. Probably not likely, and it wouldn't be a bad design, but it's not like the super simple, cool, hard to think of way I'm thinking. Maybe like one more minute. There's one way that you can get it. The boots go through exactly the same conditions. Not yet. Not yet. Not yet. Alright, everybody's got it. So, what is it?
One boot
on each foot. So, if I got the new boot here, the old boot here, they're going through the exact same conditions, right? And there's no lurking variables. You do still have to randomize. You have to have randomization in every experiment. So, what would you randomize? Which boot, right? So you'd say, flip a coin, comes up heads, the new boot was on the right foot, the tails, the new boot was on the left foot, or something like that. So I just think that's a cool. I'm not gonna type it out. Does that make sense?
Yeah.
Part B could be double blind. You just gotta say yes. You don't even have to like describe the person behind the curtain. You can just say yes if the person getting the boots didn't know which boot they were getting, and the person giving them the boots didn't know which they were getting. So You don't even have to say how, they just said it's possible. But if you wanted to say how, you have to say, like, there's a third party that gives the boots to the experimenter, and the experimenter doesn't know, and then the experimenter gives them to the subject, so the subject doesn't know. At the end, like, everything kind of unwinds, so we give everything back to the third person. They take it from there. Question on that one? Yeah.
So the double blind, wouldn't it be like not the best option to go double blind? So like the experimenter at least knows.
Well, if the experimenter knows their thought process or their bias could be put in there.
Yeah.
Like say I'm the experimenter and I work for the company that made the new boots, and I know that you have the new boot on the right foot and the old boot on the left foot. Well, I want the new boot to be better, right? So I might like kind of cheat my ratings or somehow. So the less like influence people have on it, basically, the better it is, because every people, all the people have bias. Everybody has some sort of bias in their brain. All right, let's look at the other two, the ones you had for homework. Do you get what I'm saying, Riley?
Yeah. What if a random stranger was the experimenter just testing out results?
That's better than if they work for the company, but they're still going to have some sort of. They still might. Is it?
Like if they wanted to figure out which book to buy. So
yes. So I would just say, is it possible this random person would have some sort of bias?
Okay.
Like they might not, but if it's possible and we can eliminate it, then that's fine. Okay. This one, you can't see that at all. So this window one, we want to test if window type A or window type B works better. I'm a builder. I own this company, and I'm going to build a bunch of houses, and I want to buy my windows from a certain company. Well, they both send me samples, and I want to test them to see which one works better. So something like that. And I've got this one house where I'm going to test this on. Well, what's the big lurking? So what I'm really after, the explanatory variable, is the window type, right?
Yeah.
Is A or B better? What's the lurking variable that's really going to affect how a window wears out?
Like the location of where they're located.
So, like, the sun comes up in the east, rises in the west, so that the east and west are going to react differently than the north and south. There's wind that has, like, depending on where you are, it might usually come from a certain direction. So the weather, the direction it's facing, really matters. So remember, in a block, the first thing you do is split into the lurking variables. So what I did was block, so these two are one block. The north just is a block. And then what I'm going to do eventually is randomly give one of them window type A and one of them window type B. And let's say when I do that, let's say that this comes out to, this randomly gets A and B, and this one comes out to be way better. I know it's because of the window type, right? Because they're both facing north. So that's the idea. And I would make this a block, and then I'm going to randomly give two of those A and two of those B. I would make this a block, and I would make this a block. You could also, some people didn't like the idea, so a lot of people ask, can my blocks be different sizes? They absolutely can. We've done some where like we have 600 people, but it's 400 males and 200 females. Totally fine. Your blocks can be different sizes. If you're not comfortable with that though, like some people are kind of OCD about it, no, they need to be. You could have gone with like these two because they're both southwest. These two are both, due west. These two are both northwest. So that's another option, and you could do either one of those that you want. Questions on how to split up the blocks? How many did one of those two methods? Is there another one someone wants to run by me? What about this one?
It's kind of the same thing. Yes. Split up.
What'd you do?
Just like south, north, east, west.
So like these two and these two?
Yeah.
Totally fine. Yeah, same idea, right? And then part B asks, how would you assign the window types to each numbered window boxes? So this is the put the numbers in the hat. And I had different size blocks. So I just said, after you mix it up, the first half pulled out. So, if there's 4 in there, half I'll pull out 2. But if there's only 2 in my block, half means I just pull out 1. Yeah. So, first half I pull out, get window treatment A, second get window treatment B. And then what I'll end up with, and I think this might help some people understand. Anybody got a coin? Coin? Here's a coin.
Oh, it's okay. Okay.
Flip that. Comes up heads, this is getting window type A.
Tails.
Flip it again.
Tails.
Flip it again.
Oh, heads.
Flip it again.
Heads.
I already forgot what I said.
Heads is A.
Alright.
Tails. Tails.
Alright. So this is what I think some people are missing. By doing this, I'll be able to look and I'll have, so window, or type A will be in 9, 10, 7, 4, 2, and 1. And so this one will have 3, 5, 6, 8, 9, 11, 12.
Mine's an A.
Is that right? Okay. So don't I end up with a good mix? Like I've got some here facing every direction. I've got some here facing every direction. So the whole point behind this is if these come out better, it's pretty darn convincing that window A is better, right? Because we separated them and we got some from each direction there and some from each direction there. Another thing is it possible that like window A works better on the east and west? Window B works better north and south? That's one of the benefits of block, right? You might find out this extra information. Right. Any other questions on this? So, if I gave you this problem exactly, could you do it? I tweaked it slightly. What do you think you actually have? What's the other thing? That's what we're going for. Alright, next one. Question. This is where you get to throw a bunch of dogs in a bag. So we've got a bunch of dogs. We've got 2 supplements they want to give them. They got glucosamine and chondroitin. Those are both like for joint health. Like I take them every day. So if you just gave half of the dogs chondroitin and you gave half of the dogs glucosamine, would you have any idea if those things are even effective at all? You wouldn't. You would just be able to compare them to each other. So let's say that, somehow I have a measurement score of how much their hip health improved. So chondroitin leads to an improvement of, I don't have any idea what this means, but an improvement of 2. Just pretend that means something. And glucosamine has an improvement of 2. I couldn't even say that. Let me start over. After 3 months or 6 months, how long is this? 6 months of glucosamine, the average hip health in dogs is 50. After 6 months of glucosamine, the average hip health in dogs is 49. Are those effective? We have no idea, right? We have to know what the control group is. So let's say that after 6 months, the control group who got nothing, their hip health is 60. Higher is better, let's say. Well, what do we know about the drugs now? They actually make you worse. But if we didn't have the control group, would we have known that? We did. Or, alternatively, this is what you'd hope for. Now, I know these both made it better. But if I don't have this baseline to compare it to, I don't know. So that's what question A is. What's the advantage of a control group? So that we have something to compare it to know if either one of them is even effective. that make sense? Part B, this is so I just numbered the dogs, because I'm humane. But I'm going to number the dogs 1 to 300, put them in a hat, mix them up. First 100 pull out, get glucosamine or chondroitin or control group of your choice. Second 100 get one of the other ones, and the last one get, like the order doesn't matter, right? Just do all 3 of them. And then part C, it says, how would you decide which one of the variables to block on? So notice it didn't even say, like, decide. It just said, how would you decide? If you decided, that's okay, as long as you told them also how you decided. So, for example, would I block based on the first letter of the street name that the dog lives on? I wouldn't. Why not? Because that has nothing to do with hip health. Would I block on dogs that had really good x-rays for their hips and dogs that had like some damage shown in their x-rays? Yes. Why? It matters, right? Like that's relevant. So the whole thing here is they just want you to say, they're not even asking you to declare which is more relevant, but they want you to say, we would block on the one that is more important related to hip stuff. A lot of you probably answered. So, but I think both answers are okay as long as you justify the reason. I could say I'm going to block on clinics because I think that the clinic it goes to is going to matter because they all get the same kind of treatment there, or they're all, in that same general geographical region, which could have something to do with it. Or I could say I'm going to block on breed because I think different breeds respond differently or have different health, conditions or whatever. The point is that you make sure you're blocking on something that matters. How's that? All right. Questions?
If you do like age, that's like the block, like older dogs, younger kids.
I think that's a perfectly valid way to do it. It's not asking this question, so you're kind of choosing between the two they gave you. But yeah, like that's a relevant variable, so that would be yeah. All right, let's go to problem 4. This is tough. This screws a lot of people up. This is tough. This really, if you get this one right, you really understand block. What? We'll see. How many think blogging style A is better? How many think blogging style B is better? Okay. How many didn't vote? Okay. Yeah, you might still be thinking.
So is this like graph part represent one plot? or does it represent all?
So there's like 8 plots there. So blocking scheme A says, I can't really see the shading up there.
It's always a left side.
Yeah, I'm gonna like shade it up. So this is saying we'll put 1 block here and then randomly give, 2 of them, what is it, trees or something?
Don't they all get like one of each tree?
No.
Oh, two varieties. Four of each.
Every plot is gonna get 1 tree. So this is saying I'm gonna group over here and give 2 of them type A tree and 2 of them type B tree. And this is saying this is my block, I'll get 2 of these type A tree and 2 of these type B tree. You gotta see which is right. You're what? Are you saying things to me?
No, she's heartbroken.
Mumbling. Sorry to interrupt your conversation with yourself. Kind of wait, right? In here. Alright, so let's talk through this. Because most of the hands that were up weren't correct, actually. So, remember you want to. So, what's the lurking variable? Let's start there.
Like, if it's closer to the trees, then
The forest, right? So, the lurking variable is how close you are to the forest. That's why that forest is there. So, is it possible that the trees close to the other trees in the shade grow differently than the ones that are like far away? Yeah. So that's the lurking variable. So we want to block based on that. So we want to split it up based on that. So let's back up. If we think integrated math affects males and females differently, would I try to make, and I'm going to block, would I try to force there to be 2 equal, like 50 males and 50 females over here, and 50 males and 50 females over here? Or would I put all the males over here and then split it in integrated math and not? All the females over here and then split it in integrated math and not? That'd be the second one, right? So think about that here. What you want to do is put all the ones that are near the forest in 1 block. All the ones that are not near the forest in 1 block. So A is better. And here's the reason. So you're going to randomly assign, let's say there's just 2 tree types, A and B. If I did it this way, I'm going to put the 4 plots of land, these 4 plots of land in a hat, mix it up. The first 2 I pull out will get tree type A. Could I end up with A, B, B? Alright, now let's say you run the experiment and B, these 2 trees grew way more. Do I know the reason? I don't. I don't know if it's because they were B or because they were far away from the forest. So if you're doing it this way, to control the randomization, you're trying to make sure the groups are evenly split, which isn't necessarily bad, but it's not block. Block is, I'm going to do it this way, put all the ones that are here, so I'm going to remove that lurking variable. So now when I randomly do it, let's say it comes out A, B, B, A, ABBA. And the two A's grew way faster than the two B's. I know now that A is, that there's no other, the lurking variable's gone because these were all close to the forest. So then I can tell A was better, B was worse, or whatever the case might be. So A is better because it controls the lurking variable of location. There's other ways to say that. If anyone wants to read through theirs, I can help you out. Is that a good way or not? Anybody say, yeah, I think.
I said it would be A because the force is short.
Yeah, no, that's good. So a lot of people had A up, but to be honest, the first time I saw this problem, way back when I was learning this stuff, I put A too. But does it make sense now why it's B? Purple? Did I say it backwards?
Yeah.
Does it make sense why this is correct? This is where I'm trying to get to. Okay. So even though I've decided to block, I must randomly assign. So remember, after you split into the lurking, you're doing like two randomized experiments, kind of. So with one randomized experiment on these four, a separate randomized experiment on these four. We still need to randomize. And so the question is why in the context of this problem? Well, like what I first thought of, and there's probably other good answers. Let's say this is north and this is south. There are other variables, right? Like it might grow better if it's more toward the north. It might grow better if it's more toward the south. Maybe there's a river somewhere over here, and it might grow better if it's closer to that. So what you're trying to do is randomize any remaining what? Two words am I going to put that? Lurking variables. I'm going to try to randomize any remaining lurking variables. So I saw one big lurking variable, which was the forest. I blocked based on that. But that doesn't mean that's the only one. This is not a complete answer because what have I not done yet? Read through the question and see what I didn't do yet. I think I answered the purpose. I'm trying to remove the lurking variables. What'd you say? Yeah, I didn't put it in context of the experiment. So this is just like a general answer that would apply anywhere. They always want you to refer back to the context of this specific problem. So I'm going to say something that relates to this problem. So I would say like, such as north or south location. Or maybe the plots themselves are different. Maybe like the grass up the soil up here sucks in the soil or soil conditions. Or distance from the river. Or like there's, as long as you're listing something that makes some sort of sense, you're gonna be okay. If you said like such as, I don't know, just make sure it like relates to the question somehow. Questions on this one? Let's kind of talk about. Hopefully, the block thing is starting to get a little more sense. Your homework is the very last two questions on here. So the 1999 problem 3, 1997 problem 2. This one is really similar to the one we just did. Let's start there because you're kind of in that mindset. Might be good. I'll say this too, and I don't think I said this, I might have mentioned it yesterday, but when I come around to check, if you leave it blank and you say, I didn't know how to do it, that is not an acceptable answer. Because the answers are online. So if you get stuck, like literally type in 1997, problem 2, AB stats, and copy. Hopefully I want you to read through it to understand it too, but you can't say I didn't understand it because the answers are available to you. So just make sure that that's not an excuse you try to use. Heard that one before. or come get help, or email me, or whatever. That's all good. I wonder what maybe you're not supposed to start a sentence with the numbers. It's the very last two in the packet. You what? But then eventually, like, I get like that too, and then later I just crash. Like, As to the OP, first or second?
Well, you can do it in an experiment too. There's no random elements. They're not controlling anything. They're just letting. They're not like. There's no control to it. They're not like. They're just like watching something happen. And just also like.
No randomization, there's no control. You didn't decide the treatments.